Hi, welcome to another Algebra 1 video. In this video we're starting chapter 3, which is about linear functions. In this video we're looking at section 1, which is about relations and functions. In this video we will learn about relations and functions. We will learn how to identify relations and functions. So what are relations? In mathematics, a relation is a pair of numbers. It's a relationship between inputs and outputs. A relation can be described as an equation. For example, an equation for a relation could be y equals to 2x. So in this case, y and x are related to each other, and therefore this is a relation. A relation could also be an input-output table. So say you had some values given by the input, say I, and the output would be our O. So let's say our number 0 corresponded to the output of 2, or the number 2 in our input corresponded to the number 4. So this is an input-output table, or you could say that 3 corresponded to 5, or 6 corresponded to 10. So the input and the output values in this table are related to each other. These pairs of the inputs and the outputs, together they form a relation. You can also express a relation in terms of words. So in your life you could say that Mary is Bob's wife. Well, in this case we know that Mary is related to Bob, as Bob is Mary's husband, while Mary is Bob's wife. So we have a relationship here. You can also express a relation in terms of ordered pairs. So you could have an ordered pair of 2 being the input and your output would be 4. So here from this table I got this ordered pair because here our input value was 2 and our output value in this relation was 4. So this is an example of a relation. Another relation could be between the input of 5 and the output of 6. That's also a relation. You could come up with 6 being related to 10, which is also from here. And finally, you can also represent a relation as a graph. So you can make a plane on which you graph the input values over here and you graph the output values over here given by y, and you get some random curve or line. Whatever you end up with, it would depend on the numbers that you got in your ordered pairs. So a graph also represents a relation. In this case, if we didn't know our values for x and y, our ordered pair would be x comma y. So these are the many types of ways in which you can represent relations. What about functions? A function is a relation with only one output value for each input value that you put in. So let's draw a table and see what this means. Let's say that you had a relation between x and y, where x was our input. And most of the times in mathematics you'll find that x is always going to be your input, while y usually is also going to be your output. So let's come up with a table which will represent this relation. So let's say you have 2, 6, an input of 3, and then 7, 4, 8, and so on. So our ordered pair in this case would be 2, 6, 3, 7 from here, 4, 8 from here, and we get 4, 10. So we're using the x value 4 again, and we'll see what this does. We get 6, 2, and we also get 5, 1. Now from the definition of functions, we know that it's just a relation, but with only one output value for each input. If we look at the table, we can see that the value of 4 is corresponding to 2 different y values. So we have one input of x corresponding to 8 and another 4 that's corresponding to 10. So in this case we have 2 same inputs, or your x, but you have 2 different y's, while the rule for function says that a relation with only one output for each input. In this case I can see that there are 2 values for y for only one input, or one x. So 4 is corresponding to 8 and 4 is corresponding to 10 as well. So this is not a function. But there's another thing to note. Let's say we swap the y's in this case and the x's for the y's. So we say that 8 corresponds to the output of 4 and 10 corresponds to the output of 4. In this case we have 2 different inputs that are corresponding to the same output. This still lives up to the definition of a function because the input of 8 is only corresponding to 4 and no other value, while here we have the input of 4 that's corresponding to 8 and 2. So this is not a function. And here we have 10 which is corresponding to 4. And it doesn't matter if you have the same output for different inputs that you put in your function. So this is still a function. So here's a summary for what I just described. If you have one input that is corresponding to 2 outputs, then it's not a function. So here we had only one input of 4, which had the output of 8 and 10. So there's 2 outputs to only one input, and that is not part of the function's definition. So this is not a function. And here we had 8 and 10, which are 2 different inputs. So we have 2 x's, and they corresponded to one same y, which is 4. And that still is a function because each of these inputs corresponded to only one output, even if the outputs were the same. Now let's talk more about graphing ordered pairs. We know that our ordered pairs are written using parentheses and the inputs of the independent variable, or x, which is your input, and then you put in your output value, or the dependent variable of the function. So let's say you had some ordered pairs of 2, 4, 4, 8, and let's say you had 8, 16. So these are some ordered pairs. Now let's graph them on a coordinate plane. To graph an ordered pair on a coordinate plane, you take your x coordinate, or the input value, which is 2 in this case, from the origin. So we would take 2, which comes here, because this is 1 and this is 2. And our output value in this case is 4. And so our output on this y-axis would be 1, 2, 3, 4. So this is where our output comes. And now we can take these two and intersect at this point. So this is where our point would be 2, 4. Similarly for 4, 8, we know that 4 is going to be at this point because 1, 2, 3, 4. So this is our 4. And we have 8 over here. So 1, 2, 3, 4, 5, 6, 7, 8. So this is our y point. And then we can intersect where those two lines would meet, which is about here. And then for 8, 16, you take 8 points across the x-axis because it's the input. So our 8 would be here. And the 16 on the y-axis, which would be here if you count from the origin. So we can drag it to this point, and we'd see that our point intersects over here. And finally, if you want to, you can connect the dots in whatever way you want to make it. This isn't a video for linear functions, but this is just a general introduction to what graphing looks like. Now let's ask ourselves, is this a function? Well, for a relation to be a function, we know that for every input value, we have to have one output value. So here we have 2 corresponding to 4, and no other input value has 4 over here. And we have 4 corresponding to 8, and there's only one value of 4 that is corresponding to 8, so far we're good. And we have 8, which is a unique value corresponding to 16. So this is a function because we have no duplicate values for x corresponding to an output. Now if you want to test if a relation that is graphed on a coordinate plane is a function, then you can use the vertical line test, which is a quicker way than looking at the ordered pairs that are graphed on the coordinate plane. The vertical line test says that if you can draw a vertical line and you move the vertical line all throughout where the graph is present, and if it only intersects one point, so in this case on this graph we're only intersecting this point and no other point is being intersected, like say there's no other value on this graph that's touching this point, then this shows that this graph is a function. Let's say you had another function that was graphed. It could be a straight line. If you drag this line where the graph is present, I could put it here. There's only one point, or you could drag it here, still one point. So this passes the vertical line test, and there's no duplicates for the input values corresponding to a different output. Or you could have a relation that was graphed that looks something like this. Is this a function? Well, if I put my vertical line here, I see that I'm only intersecting one point. Or if I put it here, I'm still intersecting one point. So this is also a function. Another relation could be something like this. Is this a function? Think about it. Well, if you draw a vertical line on this one, there's 2 intersections over here. Clearly this is not a function, it's just a relation. So this graph does not pass the vertical line test. And this is it for section 3.1. I hope you found this video helpful and you get a basic understanding of what relations and functions are and how you can use the vertical line test. Leave a comment in the comment section and provide feedback so I can improve my videos in the future. And I'll see you in the next video. Thanks for watching.